I'm really excited to have Joël Quenneville today. Here's our second speaker for the day. Joël is a software developer at Thoughtbot. He's a seasoned speaker. I really enjoy his talks. And he's currently working on a book, The Web as a Platform. Am I right?
Great.
All right. So I'm excited to hear more about that, as that comes along, and really interested in this talk. Let's give it up for Joël.
Let me tell you a story about the day the internet broke. Our story begins on a pretty regular day, and Jane is looking to buy a new set of headphones. So, as she normally does, she heads to her favorite online retailer, Amazoff.com. She signs in, finds a set of headphones that speaks to her, and adds them to her cart. Everything is going on just as normal. And yet, not all is well on this day. When she goes to check out, strangely, her cart is empty, but she definitely added the item to her cart. And even stranger, she looks up towards the nav bar and it says, "Hello, guest?" I mean, we all saw that she logged in, right? But web developers don't always get it right. Facebook is famous for not being accurate with their notification badge up there. So maybe it's just one of those facts of life of being on the web. She clicks through to see her profile and, wait, now we're back on the login page? What just happened? We're back where we started. This whole thing is having very much a Groundhog Day sort of vibe. So, like many of you, what Jane does is she pops open the network tab to try to see what's going on. I know you all have been on websites that have been buggy or not working, and that first thing you do, look up the Elements tab, look up the network tab. What did they mess up? And what she sees are all of those requests that she made, all of the different pages she's trying to fetch. And they all seem to be working well, at least in isolation. But somehow, the more emergent experience, where the requests connect to each other, doesn't seem to be quite working. And this is not just a problem for Jane. This is actually a problem for all of us. Because if we sit back and think, every day is actually the day the internet broke. Welcome to this talk. We're talking about state is the first decision that you've never made. This is a bit of a back to fundamentals talk, where we're going to dig into the problem of state on the web and how to build delightful user experiences. As very junior developers, you were probably introduced to something that looks a little bit like this client-server model, where you have a client, you have a server, and you make a request, you get a response back, and it's not just one interaction back and forth, it's a succession of interactions. You might even call this a conversation. And so, in Jane's case, if we sort of look along, we can see that happening in her network panel. And it might look a little bit like this if we did it on a sequence diagram. So first, go to the login page, get a response back. Go to the search page, again, get a response back. Add to cart, get a response back. And then finally, go to the profile page, and maybe that's not quite the response we wanted. We got a redirect to the login page, but individually, each of these interactions seem fine. They all fit very nicely in that model that we were first taught. The problem is that there's a little bit more complexity to it. In fact, what might actually be happening with a service the size of Amazoff is that you might not even be talking to the same server. They might have a whole fleet of servers, and that client, every request is talking to a different one. There is no context, no continuity, because each request talks to a new server on the other side. HTTP is built as a protocol to be stateless by design. And this can pose some challenges for us, but it also gives us opportunities. It allows us to do this horizontal scaling where we can just throw more servers to handle more traffic. If you've ever deployed on Heroku, you may have done this just by sliding a dyno slider to add more dynos. It's a great feature of the web. I want to challenge all of you to think maybe less in terms of browsers and more in terms of individual pieces of interaction. And browsers are these sort of big, fancy tools that we get to use. And sometimes I find it easier to try something that's a little bit more pared down. And so the challenge here is to say, what would this flow look like if you didn't get Chrome or Firefox to navigate through it? What if you had to do it with curl on the command line? And the big idea here is that curl is just a pared down version of the browser. Browser is a fancy way of making HTTP requests on behalf of your user. At the end of the day, that's really all it is. And so sometimes by paring down to curl, you can get some novel insights. So this is what maybe it might look like for logging in. You make a search request, add to cart, visit the profile. These are all the things we've seen before. And what you might notice is that, yes, these are all requests you make via curl, and they return responses. But in your terminal, if you're not doing anything else, each of these are independent. There is no continuity from one request to another. And in a browser, we expect continuity, but in curl, maybe those intuitions break down, and it becomes much more obvious how isolated each request is. Which leads us to what I find is a fundamental paradox of web development. Web development is all about building delightful, stateful experiences that go over multiple requests. And yet we're building on top of a protocol that is designed to be stateless. And so a big part of the craft as developers is to bridge that gap. HTTP is designed to forget. That is part of its design. So how do smart people deal with this problem? How do we bridge that gap? Yes, a lot of you are probably thinking, cookies. Cookies solve this problem, right? End of talk. Cookies are a solution, but I want to dig a little bit deeper than that. A big idea here is that you can resend your context on every request. And you can get continuity that way, just by resending the data. This is something that might sound basic, almost naive, and yet once you start digging into it, you realize that it actually powers a lot of the continuity techniques that we see. So what are some easy ways of resending state? One that's really simple is to rely on URLs. I'm a big fan of using relative links and putting path segments in the URL. For example, if you wanted to carry state about a particular language that a user has chosen, if you have a relative link under an /en path, all of the links on that page will stay under /en. But then if you have the same page rendered under /fr or /es, all of that just happens automatically. Very little thought has to go into this. And that takes me to one of the core lessons here, which is to use the platform. You don't always need a fancy solution. The web more broadly, HTTP, the protocol, browsers, all the different components we work with give us a set of tools, and sometimes with almost trivial amounts of effort, we can create experiences that are stateful. But we can't all do it via URLs, right? So what about something more complex? What about a multi-step form? That's clearly something where you need continuity from one step to another. Let's consider a checkout flow. And in this checkout flow, we want to pick up first address, then a shipping method, and then finally confirmation of your cart that yes, these are the items that you want. And we're sort of used to building these sorts of things, and so we all immediately go into, yeah, how do I build multi-step? But one thing we can do is step back and ask, what does the server actually want? And the answer is the server doesn't want multi-step. The server just wants to process an order, and if we were building this and optimizing for the server, we would build one giant form with all of the data and send that all at once. But that's not what Jane wants. We saw earlier when John was giving his talk, the idea of care for people, care for the user. And so when we're building delightful experiences for people, we have to ask, what do they want? And the best experience for Jane might look something more like this. So we have a step for shipping, a step for picking your delivery options, and then a confirmation step. So how might we build this? We can actually do this continuity from one step to another using forms. And so the text here doesn't really matter. It's just a form for that step 2 where we pick the shipping type. But what I can add to that step 2 are a few hidden fields, and they carry state from step 1. Here's how the technique works. Step 1, Jane submits her address. That goes to the server. The server then returns a form for step 2, but with the address data hidden inside that form. So now, when Jane submits step 2 with her delivery choice, it also carries the address back to the server. Now the server renders a new page. It's not even a form this time. It's just a page with some text showing your choices, but inside it has hidden address delivery items. That confirmation button looks like it's just a confirm button, but actually it's submitting a form with all of these values. So on the final step, when Jane hits confirm, you're sending address delivery items, all of them together, and would you look at that? That's what the server wanted. That what the server wants step, we're now doing that. The server processes it, and yay, our order is confirmed. What we've done here is sort of ping-pong that state. Client, back to server, back to client, back to server. There's no storage here. We often hear state and think of storage, but nothing has been stored. And this is a really interesting insight that came to me while digging into how we do state on the web. That state doesn't have to be storage, it can be an emergent property of the interactions. In this case, just that ping-pong relationship, that conversation. And this works even if you're talking to multiple different servers, because all of that context keeps getting passed from one to another. Wherever you are in that chain, you have all the information you need. There are some technologies that are particularly well-suited for working with this ping-pong type of approach. Talked a little bit about Turbo earlier today. Brooke will talk tomorrow about HTMX. And so lean into these. And again, use the platform. This is a pretty basic property of HTML forms. They have hidden inputs. And all of a sudden, we can construct a system where state emerges on a stateless platform. But what about Jane's original problem? That shopping cart that would not persist. We could use that ping-pong technique that we saw and thread that cart via every URL and every form, and that would get tedious really quick. What we really want for a cart is less of a linear flow and more of an ambient context. And for this, I think it's really useful, again, to go back to curl. So here's what a few interactions might look like with some ambient context if we were threading that cart through. So we're doing a search here, and we have a few cart variables that are being passed along. Now we're adding to cart, and again, a few ambient cart variables that are being passed along. And now we're doing a checkout, and again, some ambient cart variables that are passed along. It gets annoying to resend that cart state on every request. And if you're like me, you see that repeated set of cart variables on every curl request, and you ask yourself, can I dry this up? And so maybe this is what you do. You decide, you know what? I'm going to write a harness around curl, and it is going to read from a cart.txt file and just append those extra variables at the end of every request. It might even intercept responses, and in response to that, add or remove things from the cart text file. A relatively simple thing. Hey, congratulations. You've just reinvented cookies. Who knew that a little bit of pain with curl would lead us to build a core browser feature? And this is how it actually works in browsers with some headers. The implementation of that doesn't really matter that much, but the core idea is augmenting our state with just a little bit of memory to create something ambient. And I want to sit with this a little bit because what we've done is kind of categorically different than the ping pong approach we looked at earlier. Ping pong worked because of the interactions. There was no memory. What we've done now is, even though the system as a whole is stateless, we now added a memory component to part of the system. Just because a system is stateless in the aggregate doesn't mean that parts of it can't have memory. But adding memory to the client doesn't necessarily make the system as a whole stateful, because remember, we're still potentially talking to multiple different servers, and each request is treated independently. Rather, the cookie system creates memory through the same process that we've been looking at this whole time. Resend the state on every request. The memory just makes it a little bit easier for us. But since we can add memory piece on the client side, you might ask yourself, does that work on the server side? And yes, you could add memory to your servers. Servers are just programs, and programs can have memory. But remember, we're dealing with potentially multiple servers. So if I add memory to server A, server B and C don't necessarily have access to that. We're back to that multiple servers problem. We might solve that by creating memory that is shared between all of them. And most classically, this is a database. Great, so we solved the problem? Sort of, but there's also now a new problem. Previously, all of the solutions we talked about were almost private. They're part of a conversation between just you and the server, and either you're sending it some extra data or you're ping-ponging back and forth, but it's just your cart bouncing around. When we deal with multiple servers talking to multiple clients, all of whom are putting their carts in the same database, now we have to ask not just give me my cart, but say whose cart do we pull from the database? And a big aspect of server-side state is that now you're going to have to rely on passing some kind of reference. And a reference can be as simple as a parameter in the URL. So say, hey, give me a checkout for cart 1. But it could also be a session ID in a cookie, or a hidden identifier in a form. Any of the mechanisms that we've seen so far can be used in combination with server-side memory to be a reference. And I showed a database as a server memory, but it really doesn't have to be. Anything that's a shared memory that is accessible from any of the servers can work. And so you might have a key value store. You might even do just raw files on S3. There are a whole set of server-side techniques that we can use to handle memory. And this talk is not where we're going to go in depth in all of them, but feel free to come talk to me afterwards. But now that we've played around with some fancier techniques, I think it's time we could go back and rethink that checkout flow. Could we use some of our insights to build something a little bit differently? And again, I want to remember, what does the server want? In that checkout flow, the server wants effectively one giant form with all of the data at once. We've seen the idea that browsers are basically just a fancier version of curl. They're machines for making HTTP requests and sort of a nice interface for doing that. But there's another perspective that we may have for browsers, separate from HTTP, separate from even any kind of networking. And that is that browsers are a JavaScript runtime. I could write an entire desktop program that never makes an internet request and runs in a browser. And you're fully detached from that request response cycle. So from this perspective, given that we know that Jane wants 3 steps for her best experience, but the server really wants one big data dump, can we use that to maybe rethink the way that we build that flow? What if we broke out of the request-response cycle? What if we don't send all of those intermediate steps? Maybe we could have something that looks a little bit more like this. So we have a JavaScript program in the browser and captures address, but does not send it to the server, captures delivery, does not send it to the server, captures items and confirmation, and once all of that data has been accumulated, then makes a single request to the server gets what it wants and sends back that order confirmed. And so now we've gotten what Jane wants, what the server wants, all in one experience. This is another reminder again, use the platform. Thinking about what a browser is. Are you using it as a HTTP request builder? Are you using it as a runtime for a JavaScript program? Are you intermixing the two? If you take time to think about the tools and the mental models you have for the platform, it can help you build the best possible experience for the particular customer you're trying to serve. We've seen a variety of techniques, and these are not an exclusive list. There are a lot more, but this talk is not really to teach you all the techniques on how to do state. Rather, I want you to think a little bit about what the platform offers and what sorts of problems you have to deal with when you're thinking about state. But in general, I find that they sort of live in these 3 families. So state can live on the network. It's not stored anywhere, it just is an emergent property of the conversation. It can live on the server in some kind of storage. But if you use that approach, you probably need some kind of reference. It can live on the browser, either through something like a cookie, which is just sent on every request, or if you build a full-on JavaScript application, it can live in the JavaScript applications memory. And now you maybe even decouple from the HTTP back and forth request-response cycle. And I should note that combos are common. You're never setting out to say, I'm building an app that is entirely on the network or entirely in the browser. I mean, there are probably extreme cases where you could. But in reality, you're going to use a combination of this, not just on an app, but even on a single feature. And in fact, some of the examples I've shown you have already done that. If you remember talking about the idea of passing a reference to the server to maintain that state, that reference is using some of the techniques we saw from the ping pong approach. That ID that maybe follows you around in the URL, or a session token that lives in your cookie that gets resent on every request. That's techniques from the state on the network family used to enable a state on the server strategy. We've also been really focused on the idea of taking independent requests, which is what HTTP gives us, and stitching them together to make a cohesive, stateful experience for our customers. But state is more than continuity. Continuity is the core, but we need to think beyond just continuity. Again, there are a lot of these different other aspects that matter. We're not going to go into them in detail, but rapid fire, here are a few. You might want to consider shareability. What if Jane wants to share her cart with her partner? She puts some items, says, hey, anything you want to add before I check out? Or what if Jane starts on a laptop, but then wants to check out on mobile? These questions and how you answer them are going to impact what strategy you use for managing state. Because state is now no longer just moving from one request to another, but maybe from one device to another. You might also want to care about resumability. Right? What if Jane refreshes the page? Does she lose her cart? Does she lose her entire session? Does she get logged out? The way you think about state and the way you implement it are going to have impacts downstream. And of course, we've got to talk about security, right? All of this data that's in your state is things that hackers might want to use. A URL like cart/123/checkout allows someone to have access to an arbitrary cart. Sometimes that's a feature. If Jane wants to share her cart with her partner, having a URL she can share is really good. But it also means that I can go in and just change that number and get somebody else's cart. And maybe now we have a really bad privacy violation. Any state that lives on the client, URLs, forms, cookies, those can all be manipulated. And so even though you have that conversation, you can never truly trust what the other partner is saying. Remember a bigger idea that web browsers are just a fancier graphical curl? I find this perspective is really helpful when thinking about security. Oftentimes, I can be blinded by the UI that I build. Only these fields will get set, or they will already come in here and have a cookie set. But if you can curl with different values and your server accepts it, you're not secure. And so thinking in terms of what could curl do rather than what are the limitations imposed by my UI helps you to be more in a security mindset. And this is something that I find myself falling to. I think it's a very common pitfall for more junior developers. This is something that I often, when I'm sitting down with someone who's newer to our industry, really try to drive home when they're trying to learn how to think about security. We might also want to think about performance, right? The way we deal with state is going to have impacts on performance. There are a lot of aspects to performance, but one of them is data transferred over the wire. If you want to do operations on the browser side of things, typically that works best on smaller data sets. You don't want to download the entire product catalog from Amazon.com onto someone's local browser just so that they can execute a search. That would be kind of ridiculous in terms of the performance. Also, that catalog might change, right? Some administrators might be making changes in the background, and now you've got a stale copy. And now you've got to figure out how to expire that data, how to refresh, know what's stale. Distributed systems are hard. Let's just admit that. More broadly, while we've been talking about all these other aspects, I want you to think about how trivial decisions can have big downstream implications. If you pick a state strategy at random, it might have all of these impacts that you didn't quite consider at the beginning when you were designing your app. And sadly, state is something that's often downstream of unrelated decisions. We make technology choices for our stack based off of a lot of other considerations. And state is sort of often just sort of left to be a downstream impact of that. You might have a colleague who's just like, let's use React. Or maybe you have a colleague who's like, just throw it in the database, it'll be fine. You might even have that colleague who just thinks that microservices are dope. State is often a decision that you don't consciously make, but you absolutely will have to live with. So how do we fix this? How do we try to think more consciously about state? I think it goes back to what John mentioned in his talk in the previous session, right? That putting the user first. Ask yourself, what does Jane want? What is the delightful, stateful experience that she needs? Because at the end of the day, that is what you are trying to ship. You also have to think about what the server wants, right? The technical limitations of what you're working with. And then ask yourself, given what Jane wants, what the server wants, where should state live in order to bridge those two? And don't forget to use the platform. The browser, HTTP, the protocol, the web in general gives us a really rich array of tools that we can use to bridge these two, to think about state, to navigate the trade-offs of all those different properties that we care about. But we have to think holistically. We have to use the platform that we've been given. And ideally, we make state a conscious choice, not one that just happens to us. Ideally, state becomes the first question that you answer when you're building an app from scratch or whether you're building a feature. Technically, that's the third question, because the first question should be, what does Jane want? Then it's, what does the server want? Then you ask about state. But saying state should be the first question you answer looks better on a slide. Also, I want to challenge the idea that state is about storage. State is often implemented as storage, but it's much more than that. Going back to that early metaphor from the beginning of the talk about interactions being a conversation between client and server. State is the connective tissue of your conversation. It's what moves you from not just one back and forth, but a whole series that are chained together. You can think of it as context for a whole set of interactions. And in the current moment, if the word context maybe makes you think of something a little bit different than the web, that's natural. It turns out that the web is not the only stateless system out there. LLMs are also stateless. So how do smart people deal with statelessness in the LLM world? You know the solution. You resend context on every request. So let's say that Jane is going to ChatGPT to troubleshoot. And she says, okay, where's my cart? Where did my cart disappear? And ChatGPT responds with, well, you know, the web is stateless. And Jane says, all right, well, how do we make it remember? And notice that on these arrows, right, we're accumulating state. When Jane makes that second request, she's not just adding a new question, she's resending the entire conversation. And then the server responds with, well, you know, there are these three families of solutions. And what you might notice if you zoom out a little bit is that this accumulation of state via back and forth is the exact same thing we did with the ping pong approach to doing our HTTP checkout. This is the same solution applied to a different type of stateless system. We don't have time today to dig into how statelessness works on an LLM, but if you were, you might notice that a lot of the techniques that I talked about for HTTP also apply here. And if you want to come find me afterwards, or you've run into me throughout the next few days, I'd love to dig more into this. Some of the harness stuff and how it lines up with like cookies or whatever, really cool. Statelessness is a kind of a fundamental problem of a lot of software that we build. It's not just a web thing, it's not just an LLM thing, it's a whole class of problem. And when we start to think about the sort of timeless solutions for it, we start to see patterns. And hopefully by working holistically with our platform, we now know how to make every day the day that the internet worked, not the day the internet broke. And maybe not just the internet, maybe it's the day the LLM worked as well. Thank you for coming to the talk. I'm Joël Quenneville. I'm a principal developer at Thoughtbot. We are a web development agency who are specialized in building delightful, stateful experiences for customers. If that's something that you're interested in, would love to talk to you. I co-host a podcast called The Bike Shed. And as Jeremy hinted, I am the author of a book, The Web as a Platform. This is the book I'm in the process of writing, and it's all about taking a holistic look at the web through the lens of seeing it as a platform. You heard me throughout the talk sort of multiple times say that refrain, use the platform, think about the tools, see the big picture, think holistically. And that is that idea as a book. In fact, this entire talk is based off of chapter 10 from the book, The Problem of State and Building with State on the Web. If you'd like to be notified when the book launches, got a QR code or a URL, you can go there. I'll just send you an email when the book goes live. Thank you very much.